Hi everybody, today I'd like to share with you some examples of how I plan to or have used ASU Sync in the past in my FSE100 Introduction to Engineering and CSE325 Embedded Systems Programming courses. The first one that I'd like to share is the decision matrix example, and in this one we're learning how to use decision matrices in how to develop and use decision matrices in the FSE100 Introduction to Engineering class. And we play with this example, and this is just a fun engineering example. It takes about 20 minutes, and the idea is to come up with a approach, a solution to getting a whole bunch of eggs from point A to point B. And in between is the Great Wall of China, a really big wall. You can't go around it. You can go over it and you can go under it, but you can't damage it. So that's the idea here. So we have a whole bunch of eggs. We have a whole bunch of people on the other side that we need to feed. And how do we get eggs from point A to point B? So the first part starts off with giving the students about 2 minutes using Zoom breakout rooms to come up with a bunch of ideas. And I want them as a group or even as individuals to come up with 2 to 3 solutions that they think would be good. And they can range from serious solutions to crazy, wacky solutions. The idea, I give them constraints of using today's technology. So no teleporting, no time travel, any kind of crazy stuff like that. Then what I do is ask the students to recommend 3 evaluation criteria, and I do this either through Zoom chat or just by students sort of raising their hand and asking a question. Usually I don't do the asking the question part over audio because multiple students will talk over each other. The Zoom chat is a good way to gather a whole bunch of information really quickly and get that to me as quickly as possible, right? And it doesn't matter in either of these cases whether the students are in person or on remotely. I want all the students that are in person to also be on Zoom so that they can coordinate with the students that are remotely in class as well. Right, so typically the students answer with cost, safety, and speed. Cost being the implementation cost, the running cost, and maintenance cost. Safety, how many eggs and how safe are they to eat at the end of the travel at point B, and then speed, how fast can we deliver eggs from point A to point B. Then I set up a paired comparison. So these are Zoom polls that say what is better, which one is more important in terms of the criteria between cost and safety, safety versus speed, and cost versus speed. So we do 3 polls, and I can tell which one, and the students vote on each of these comparisons, which one is more important. And then looking at those, I can tell how many people have voted in each one and the total. And then using that, I can calculate the criteria weighting for the decision matrix, right? Then the next thing that I do is open up a Zoom whiteboard or share my screen in Excel, and I set up the decision table with the criteria down the side, the weighting for each of the criteria in the first column, and then I have 3 or 4 columns for different design ideas. So then I ask for, through the Zoom chat, I ask for 3 or 4 design ideas from the students, and those there's always a catapult, there's always a tunnel underneath with like a conveyor belt, there's always some kind of like rope system that goes over, and then some of the more modern ones are like a drone system or a helicopter that flies eggs from point A to point B and stuff like that. We compare all these different ones based on the criteria and the criteria weighting that they've calculated. So then as I'm discussing these ideas, the team, my TA is setting up the criteria rating polls for each of them. So I say for the cost for the cost criteria, which one of these is going to cost the most, right? So rather than arguing about the specific points that go in the decision matrix, I ask them which one costs the most, and then I give that one a cost of like 1, right? Because cost lower is more cost, the higher one is less cost. Higher score is less cost, right? So I give that one a 1. The number 2, I give it a 5, and number 3, I give it a 10, right? And we just sort of run with it that way. And I do that the same for the safety criteria, the speed criteria, and that finishes out the table. And once I put those numbers into the table, we can collect the data from these polls, put those numbers into the table, plug in the values, and then calculate the winning design. And this all takes about 20 minutes, right? So it's a significant activity, but there's, let's see, 5 interactions here. So the students are active the entire time. They don't have time to get bored. They don't have time to even get distracted because something new is happening. I'm asking them to interact in some way every couple of minutes, and we go through an example that involves them, and it's a good time because we're talking about crazy ideas for getting eggs from point A to point B, stuff like that. So it's a really good activity for making sure the students are engaged and they stay engaged. Another one that I do in my CSE325 class, the Embedded Microprocessor Systems class, is this class is focused, it's a junior level class, it's focused on programming for embedded systems and stuff like that. And one of the things we want to teach is the entrepreneurial mindset and the design application. So this is a flipped classroom. So the students watch lectures online about sort of the more technical aspects of a design or a programming tool, and then they come to class and we do activities. And some of these activities are based around what I'm calling mini projects for design applications. And we go through figuring out for each of these, who is the customer, what do they care about, what is important about the design features of that device, and then let's look at, based on that, let's look at how we would design this, what parts of the embedded system, what parts of the microcontroller would we use, how would we use them, and things like that. And then we wrap it up and talk about how the design choices affect how we think the customer will enjoy or find value in the design choices we made. Whether we made design choices that fit the customer's needs, or whether we went against it, or we weren't able to meet those needs because of choices that were made for us. Right? These are activities that are typically broken up into lots of little pieces. So we talk about the who uses this, what do they care about part, that takes about 5 or 10 minutes. Then I look at the design overall and say, okay, what are the components? What is the input? What is the output? How are we going to display information? What is the software pieces? And I have lots of little design choices sort of laid out, and we adapt. I basically adapt. There's no one way to do this, but I ask the questions of what are the questions that we should ask as we go, and we have a in-class discussion about it. And I facilitate this. I did this in the spring when we had this class, and the way that I facilitated it was we had these questions, and people would suggest them. I would call on a specific person and they would suggest a design. I would typically ask the class to think about it for a few minutes. If I had a more involved environment or a more involved challenge for them where they had to do some programming, I would push them into breakout rooms and they would collaborate using Google Docs or shared screens on a small snippet of code or something like that. And then I would call on a specific breakout group in the main sort of Zoom room and ask them to present their solution. They could share their screen, they could show what it was. And this is a great advantage because rather than having one sort of central screen in the classroom and I can't really get my students to share it with me, I now can call on a specific group, whether they're in person or on Zoom, and they can share it with the entire class, and I can see what they're doing and what they're talking about, what concepts they're struggling with, and that's actually a huge advantage. So some of the collaboration tools that I used in CSE325 are the Canvas discussion boards. There's a bunch of cool features here. One of them is being able to thumbs up or like a post. So you can use it for having class rankings of things. The Zoom and breakout rooms for everybody, including the students that are outside of class or inside of class, is extremely helpful. And that allows everybody to collaborate and have a common space that is online, and it augments my in-class experience. The Zoom chat for sharing links is really good because rather than having a link up on the board and having to share the slides through Canvas, I can post a link to the chat. Again, since everybody is on Zoom, they all have access. They can all go to the website, see what I'm talking about, and I can get immediate feedback using the poll system or something like that. In-class TA, this is something I haven't tried out yet, but what I'm going to try out in the fall is using a TA as an online moderator. So the TA is online, they're on Zoom, and if I'm talking about the something and I'm not paying attention to Zoom in my classroom, I'll be looking to the TA for feedback and for them to raise their hand in the real world and tell me, oh, the Zoom chat has this question, and stuff like that. And that way I have a representative, and I actually can't ignore the online class, which I think is important. Google Docs is always a really great shared note space, a great place for shared calculations in Excel and collaborative writing in Google Docs. And a really excellent tool for programming is called the Replit Multiplayer, and it's repl, repl.it. That's the website, so go to repl.it, and then you can sign up for this space, and students can too. It's totally free, and they have a tool called collaborative coding, and it's a collaborative code space. It's a shared code space, just like Google Docs, where students can they can work together, and you have multiple cursors inside of code, which is something that is fairly rare, and that allows them to code in a very large number of languages. They support C, Java, Python, MATLAB, they have Jupyter notebooks, they have all kinds of cool stuff. So if you're using any kind of coding in your classes, I would recommend doing this. It's really, really neat, and it allows the students, if they're in person or online, to collaborate on a single piece of code, see it execute. They can share their screen over Zoom with me. I can see what they're working on. We can have a class discussion about it and do live problem solving, including seeing what their things are. And they can be over there. I can be over here. I don't have to get close to them. They don't have to get close to me. And I can effectively look over their shoulder without getting close enough to look over their shoulder, right? Things that you should consider when you're doing this is I found flipped classrooms to be really good. There's a lot of me talking to students in Zoom immediately gets them bored. There's so many distractions. There's so many things like that. It's better if they can do the pre-work, listen to me talk to them somewhere else at their pace. They take a little quiz and then come to class and do activities that I can do over Zoom and keep them engaged. That's the flipped classroom model that I use. And thinking at every step about how will your remote students interact with you, with other students that are in class, and vice versa. How is that going to work? And using these tools to our advantage. I think there's a huge opportunity here for us to improve all of our classrooms, not just the online ones, but in the future, when we come back in person, having Zoom as a collaborative workspace in class and have a tool for students to ask questions and not interrupt me. I can address questions when I'm ready. Students can write the questions when they have them, and we can collaborate over Zoom by sharing screens and sending links and stuff like that. I think that's incredibly powerful. Even over Slack or something like that, those are great. And make sure to prepare your TA or UGTA. The FSE100 example is a great one where having the script of what you're going to do, having a lesson plan and going over it ahead of time, and make sure the TA is prepared for calling on them and setting up the poll in the background, giving them co-host rights in Zoom so that they can set up those things and then activate them when I call of them. They can be sort of like my producer in the live session. All of these things can make these ASU Sync classrooms not only rich and engaging, but they can make our future classrooms better as a whole, and it's a really exciting opportunity.